Good afternoon, class. We are looking at analytic trigonometry or trigonometric identities and equations. Here's trigonometric identities. So we covered trigonometric equations. Now we are going to cover trigonometric identities, and the objectives are: use algebra to simplify trigonometric expressions, establish identities. Reminding you of some stuff we have already seen, the inverse functions, the inverse sine, cosine. Remember, none of the trigonometric functions are one-to-one. None of them has an inverse. Therefore, by restricting the domain for each one accordingly in order to cover the entire range, we can make it one-to-one. In the case of a sine, from negative pi over 2 to pi over 2, y is from negative 1 to 1, makes it a one-to-one function. And the graph looks like that. Y equals sine inverse x means x equals sine y. And f inverse of f of x equals sine inverse of sine x. And it's equal to x, where x is between negative pi over 2 and pi over 2. And f inverse, f of f inverse, that means sine of sine inverse x. Then equals x is fx between negative 1 and 1. You have to look at this one pertaining to sine inverse, this one pertaining to sine x. We do the same thing for cosine, but for cosine, we go from 0 to pi in order to cover the entire range. For tangent, similar to sine, we restrict it to negative pi over 2 to pi over 2. The difference is, in the case of a sine, the endpoints are included. In the case of a tangent, the endpoints give rise to vertical asymptotes. They are not included, and therefore we have a one-to-one function and its inverse. Now, 7.1 part 2, trigonometric identities. The term identity refers to an equation that is true for all values of the variables involved. These equations establish fundamental relationships that are used to simplify expressions, solve equations, and prove various mathematical properties. F of x equals g of x. By definition, the two sides of an identity are interchangeable, so we can replace one with the other at any time. An equation that is not an identity is called a conditional equation. That means it works at specific, values. And so fundamental identities we have seen, just reminding you of x squared plus y squared equals 1, which is the unit circle, and a point has coordinates x comma y, sine is y, cosine is x, and the rest follow accordingly. Trigonometric functions, they're all periodic with the period of 2 pi, with the exception of tangent and cotangent with the period of pi. That means you can add 2 pi or 2k pi for that matter. They are all odd functions with the exception of cosine and therefore secant. They are both even functions. Fundamental identities, Pythagorean identities, cosine squared plus cosine squared equals 1, tan squared plus 1 is secant squared, 1 plus cotangent squared equals cosecant squared. Quotient identities, tangent is sine over cosine, cotangent is cosine over sine. Reciprocal identities, cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. These are the identities we had seen, and hopefully we are comfortable with all of those identities, okay? All right, use algebra to simplify trigonometric expressions. We want to simplify tan theta over secant theta by rewriting each trigonometry function in terms of sine and cosine. By the way, even if they don't mention it, normally most of them we change to sine and cosine. That means not only a tangent, also cotangent, also secant, also cosecant. Normally that works. So with that being the case, tangent becomes sine over cosine and secant becomes 1 over cosine. It's a complex fraction. Since the denominators are identical, you can drop them or do the, uh, multiplication of sine times cosine, put it at top, okay? And cosine times 1, put it at the bottom. Either way, you get sine over 1 or simply sine, okay? Show that sine theta over 1 plus cosine theta equals 1 minus cosine theta over sine theta. And they have given us a hint by multiplying the numerator and denominator by 1 minus cosine theta. This is a technique that we learn and we can follow that. So we start with the left-hand side and we multiply and divide by 1 minus cosine theta. So what happens? It's very simple. When you multiply, the denominator, you write it as 1 minus cosine squared, and you keep the numerator as is. That means sine times 1 minus cosine. 1 plus cosine times 1 minus cosine is 1 minus cosine squared. And this, we can replace it with sine squared. This sign goes away. So go with a different color here. So we can get rid of sine theta. We can get rid of the exponent. And this is the right-hand side. So it's pretty straightforward. I hope everybody is fine with that. So even if they didn't give us the technique, by practicing, we should be able to figure this out, everybody, okay? We should be able to figure this out. Establish the identities. Cosine theta over 1 minus sine theta is equal to 1 plus sine theta over cosine theta. You start from one side. For example, if you start with the left-hand side, we're going to make it look like that. We're going to multiply the top and the bottom by 1 plus sine theta. We're going to multiply the top and the bottom by 1 plus sine theta. So what happens? We keep the numerator, the denominator becomes 1 minus sine squared. And we are using, in essence, the technique we learned from the previous page. And we know 1 minus sine squared can be replaced by cosine squared. And we can get rid of the cosine from the top, exponent from the bottom, and that is the right-hand side. One other way, we could do the cross product. One other way to prove this, if you do the cross product and show the left and right are the same, remember, a proportion is a true proportion if the cross product is true. So you can do the cross product. That's another methodology. Normally, most texts, they like to see you start from one side, you end up the other side, but cross product is just as good. Use algebra to simplify trigonometric expression. The hint is to use the LCD. But even if they don't give us the hint, we should recognize that we are adding two fractions, and the LCD would be the product of the two denominators. That means I'm going to multiply 1 by 1 plus sine u plus 1 times 1 minus sine u, and the denominator is 1 minus sine u times 1 plus sine u. In other words, the first fraction, I'm going to raise it by multiplying by 1 plus sine u over 1 plus sine u, whereas the second fraction, I'm going to raise it by multiplying by 1 minus sine u over 1 minus sine u. And of course, now the denominator in each case is 1 minus sine squared. So this is 1 minus sine squared. This is 1 minus sine squared. So all you have to do, add up the numerators, and of course, when you distribute 1, nothing changes it. This becomes 1 plus sine u, this becomes 1 minus sine u. So when you add them up, these two cancel each other, and the numerator is 2, and the denominator is cosine squared. And secant is 1 over cosine. So 1 over cosine is secant. So you have 2 secant squared u. B, 1 minus cosine squared v over sine v plus cosine v sine v. Do this by factoring. Again, the technique they are giving us is the factoring. We don't need that in case this is not given. We should recognize the top is 1 minus cosine and 1 plus cosine because it follows a squared minus b squared. Because remember, 1 is 1, 1 squared, 1 cubed makes no difference. So the top is 1 plus cosine and 1 minus cosine. The bottom, you can factor the sine out. You get sine times 1 plus cosine. So this is a simple factoring, everybody. So the numerator is 1 minus cosine and the denominator is sine. And we can make up two fractions, everybody. This is 1 over sine minus cosine over sine. And we know 1 over sine is cosecant. Cosine over sine is cotangent. Therefore, we have cosecant v minus cotangent v. We are using algebraic techniques to simplify trigonometric expressions. We're going to continue with more examples. Clearly, we have to use the LCD here, even if it's not mentioned. So, what is the LCD? Sine u times cosine u. Therefore, this one you have to raise it by a factor of cosine over cosine, and this one by a factor of sine over sine. And whether you write this step or not is not important. You are a pre-calculus student. You should recognize that. And so the denominator in both cases is sine u, cosine u, in any order you want to write it. Sine u, cosine u, or cosine u, sine u. And we're going to multiply the top here. We get cosine u plus sine u, cosine u. We're going to multiply these two. We get plus, and this is a plus, so we don't have to worry about anything. So we get cotangent u sine u minus cosine u sine u. So the denominator is established as sine u, cosine u, and the numerator you simply multiply to get the answer. Clearly, sine u, cosine u, or cosine u, sine u makes no difference. One is positive, one is negative. They cancel each other because they are opposites. So let's write what we are left with. The numerator is left with cosine u and then cotangent u sine u. Then the bottom is sine u, cosine u. Cotangent is cosine over sine. And I hope you recognize that we can cancel this, right? Because this is being multiplied by sine. So we get cosine u and cosine u in the numerator, meaning we have two cosine u in the numerator. We can cancel out the cosine from the top and the bottom. We get 2 over sine u. Since secant is 1 over sine, this must be 2 secant u. Sine squared v minus tan v sine v minus tan v. We want to simplify it clearly. The numerator, just a squared minus b squared, can be factored out. And the bottom, we can factor the tangent. So the top is sine v plus 1, sine v minus 1. And the bottom, if you take out the tan v, you get sine v minus 1. So factor accordingly. Again, sine squared minus 1 squared, okay? So a squared minus b squared. These two cancel each other. Let's write what we are left with. Let's change this into two fractions. This is 1 sine over tangent. And by the way, tangent is sine over cosine. And this is 1 over tangent. So the reason we do it in this format, because we will simplify this further. Sine v over sine v over cosine v becomes cosine v. I hope you recognize this. And I'm going to write it here in case. So what you're dealing with is sine v over sine v over cosine v. And I'm going to put a 1 here and say the product of these two over the product of these two that gives us cosine v, because the sine cancel out. And this is cotangent. So the final answer, cosine v plus cotangent v. So I hope everybody is clear on this. Again, pretty simple stuff as long as we are comfortable with algebra, everything works fine. Establish an identity sine theta times cotangent theta plus tan theta is secant theta. Normally, you start with the more complicated side, in this case, the left-hand side. LHS short for left-hand side. Or RHS, the right-hand side. So you start with the left. And many times, changing everything to sine and cosine will help establish the identity. Cotangent is cosine over sine, tangent is sine over cosine. Inside the parentheses, we take a common denominator of sine, cosine. This becomes cosine times cosine, cosine squared. This becomes sine times sine, sine squared. I hope you have no problem adding two fractions. So the common denominator or LCD is sine theta, cosine times cosine, sine times sine. As you know, the numerator can be replaced with 1. Also, this can cancel this one. So you have 1 over cosine theta, which is secant theta. So it's pretty straightforward, everybody. I hope everybody's fine with that. So we are using other identities to prove the new identities using algebraic techniques. Very straightforward, everybody. Cosecant theta minus cotangent theta is sine theta over 1 plus cosine theta. You can start from one side and get to the other, because normally every trigonometric function we should use normally sine and cosine to establish identities. We are going to start with the left-hand side, cosecant theta minus cotangent theta, because we are going to change them. This one, 1 over sine theta minus this one, cosine theta over sine theta. This way, we can establish the answer pretty simple. Obviously, we can write one fraction with the denominator sine theta and the numerator 1 minus cosine theta. I hope this looks familiar. We multiply the top and the bottom by the conjugate of the numerator, 1 plus cosine theta over 1 plus cosine theta. It is important to know you can do that when you have a fraction equal to 1. You can't just multiply by anything. The numerator clearly gives you 1 minus cosine squared, and the denominator, we just keep it as a product of sine theta and 1 plus cosine theta. So again, the numerator, 1 minus cosine squared. As you know, 1 minus cosine squared, it can be replaced with sine squared. And we can cross out this sign from the bottom, exponent from the top, and this is the right hand side. So we proved it. Establish identity, sine squared minus tan theta over cosine squared minus cotangent theta equals tan squared. Again, you can start with any side you want. Normally, the more complicated side in this case is the left-hand side. So we write the left-hand side. And we write everything in terms of sine and cosine, which means this will change to sine over cosine. This will change to cosine over sine. We are dealing with a complex fraction, everybody. The fastest and easiest way to fix the problem is to multiply the top and the bottom by LCD. So I hope you recognize there are two fractions, one at top, one at the bottom. This has denominator cosine, this has denominator sine. So the LCD for the entire complex fraction is sine theta times cosine theta. So you multiply the top by it and the bottom by it. So look at this. Sine theta cosine theta over sine theta cosine theta. This is equal to 1. So you're going to multiply this by every term. So if you multiply this by the sine squared, you get sine cubed with the cosine theta. If you multiply these two, cosine theta goes away, you get minus sine squared. If you multiply these two, you get sine theta cosine cubed with the. If you multiply these two, sine theta goes away, minus cosine squared. So I hope you can see that. It's a simple case of dealing with a complex fraction, everybody. Dealing with complex fraction. And so clearly, from the numerator, the common factor would be sine squared. We take it out. So it gives us sine squared times sine theta cosine theta minus 1. And from the bottom, we can take out cosine squared. So we get cosine squared times sine theta cosine theta minus 1. So factor accordingly. We can cancel this 2 and sine squared over cosine squared. Since sine over cosine is tangent, it must be tan squared. So pretty straightforward, everybody. Let's prove cotangent squared theta is cosecant theta minus sine theta over sine theta. We can start with the more complicated side. It seems to be the right-hand side. And all we have to do, change everything in terms of sine and cosine. So cosecant becomes 1 over sine. Everything else is fine. So just change cosecant theta to 1 over sine theta. Again, you're dealing with a complex fraction, everybody. So you are going to multiply by the denominator sine theta over sine theta because LCD is only sine theta. So when you multiply this by 1 over sine theta, you get 1. When you multiply these two, you get minus sine squared. And the bottom is simply sine squared. The numerator can be replaced with cosine squared. And cosine over sine is cotangent. Therefore, you're dealing with cotangent squared theta. So we are establishing identities. We start with the more complicated side. So, and this, of course, is what we were trying to prove. One minus cosecant theta sine cubed equals cosine squared. We're going to start with one side. The left-hand side is more complicated. So 1 minus cosecant theta sine cubed theta, we write everything in terms of sine and cosine. So all we have to do, change the cosecant to 1 over sine. This gives us 1 minus sine squared, and you know it to be cosine squared. And that's the end of the proof, everybody. Because we proved 1 minus cosecant theta sine cubed is cosine squared. We want to prove 1 plus tan u over 1 plus cotangent u is tan u. And we start with the more complicated side. Clearly, it's the left-hand side. So we start with the left-hand side. And we write everything in terms of sine and cosine. So tangent is, you can go with sine and cosine, but notice the bottom is cotangent. And since we want to get to tangent, then we don't have to do that. We change the cotangent to 1 over tangent. Again, you really have to look at the result that you want to get. We want to get to tangent, so we don't have to change the tangent. Now, this is a complex fraction. So we have to multiply the top and the bottom by LCD, and there's only one fraction in the denominator. So the LCD is tan u. Let's multiply the top and the bottom by. Now the numerator is going to be the product of these two, and we are going to keep it that way. What happens to the bottom when you multiply these two, you get tangent u. When you multiply these two, you get 1. So first look at the bottom. That gives you tangent u plus 1. And the top, don't change anything. Keep it as a product. Don't distribute, because now tan u plus 1 or 1 plus tan u are the same. They cancel each other. And they give us what we were looking for. Tangent u as we had it on the right side, everybody. Establish identities. We continue working on those. 1 over secant x plus tan x plus 1 over secant x minus tan x is 2 secant x. Well, obviously, the left-hand side is more complicated. We are going to use the left-hand side, and we're going to use LCD, the least common denominator, because we have two fractions to add up. The LCD, of course, is the product of these two. Secant x plus tan x times secant x minus tan x. So this becomes 1 times secant x minus tan x. This becomes 1 times secant x plus tan x. I'm assuming nobody has any problem with fractions and handling them. Okay, everyone. So all we have to do is simplify this expression. So let's do that, everybody. Let's write down secant x minus tan x plus secant x plus tan x. Let me use a different color for the numerator, and notice these two cancel each other, and these two add up to 2 secant x. That's for the numerator. For the denominator, we get secant squared minus tan squared. Very straightforward. Now, we remember from Pythagorean identity that tan squared plus 1 is secant squared. Therefore, if I move the tan squared to the other side, secant squared minus tan squared must be 1. Again, move this to the other side. Secant squared minus tan squared must be 1. Therefore, the answer is 2 secant x, which is the right-hand side as expected. Part B, sine x is minus cosine x tan minus x, and we start with the right-hand side because it's more complicated. Now, remember, all trigonometric functions are odd functions except cosine and therefore secant. By odd function, we mean f of minus x is minus f of x. So this is fine. Tan of minus x is minus tan x. You never want to have a negative argument for any of your trigonometric functions. So change them accordingly. This changes to minus tan x. Now negative and negative is positive. So cosine x times tan x, and tan is sine over cosine. These two cancel each other. And the final answer is sine x, which is the left-hand side. And we proved it works fine. So it's pretty straightforward, everybody. We are going to look at more examples. Sine x over cosine x plus 1 plus cosine x minus 1 over sine x equal to 0. Obviously, we're going to start with the left-hand side and use LCD, the least common denominator, because the left-hand side, of course, is the one that we want to prove it to be 0, or it's more complicated. And to take the LCD, obviously, the LCD is the product of these two, cosine x plus 1 times sine x. So this one would be sine x times sine x. This would be cosine x minus 1 times cosine x plus 1. I'm assuming we have absolutely no problem with fractions, combining them, adding them up. So what happens next? Let's see. The denominator is just the product of those two. Keep it. This is sine squared. And these two, when we multiply, a minus b, a plus b is a squared minus b squared. So cosine squared minus 1. So this part is obviously this part. And as you know, sine squared plus cosine squared would be 1. Therefore, 1 minus 1 is 0. The numerator is 0, and the denominator is not. The answer is 0, and that's a proof. Prove sine alpha plus cosine beta squared plus cosine beta plus sine alpha times cosine beta minus sine alpha will become 2 cosine beta times sine alpha plus cosine beta. Clearly, the left-hand side is longer and more complicated. So we're going to start with the left-hand side. To simplify and get to the right-hand side. You square that, you get sine squared plus 2 sine alpha cosine beta plus cosine squared beta. I'm hoping nobody has any problem with basic information from algebra. So I'm using a plus b quantity squared, a squared plus 2ab plus b squared. A plus b, a minus b is a squared minus b squared. So cosine squared minus sine squared. So this part is this part and this part is this part. Hopefully we have no problem. We notice that sine squared and minus sine squared cancel each other. And we notice that these two will combine into 2 cosine squared beta. This doesn't change. And we can factor out 2 cosine beta. So if I factor out 2 cosine beta, I'm left with sine alpha plus cosine beta, and I'm done. So knowledge of algebra factoring is a must. Simplify cotangent over cosecant. When that happens, always go with sine and cosine, even if they don't mention it. Cotangent is cosine over sine, cosecant is 1 over sine. If you have a complex fraction and the denominators are identical, you can drop them. And the answer is cosine x. The reason you can drop them, let me just quickly show you this class. The reason you can drop them because you multiply those two. Let me just use a different color. You multiply those two cosine x times sine x, and you put it in the numerator. You multiply those two, and you put it in the denominator. Sine and sine cancel each other, and you get cosine x. All right. Show that cosine over 1 plus sine is 1 minus sine over cosine theta, and multiply and divide the left-hand side by 1 minus sine theta. That's the hint. We have seen this before. We should have absolutely no problem with that. So let's do that. Left-hand side, we multiply by 1 minus sine theta and we divide by it. So the numerator, we keep it as a product. The denominator becomes 1 minus sine squared. One minus sine squared can be changed to cosine squared. And now we can drop this and this exponent, And it gives us 1 minus sine theta over cosine theta, which is exactly what we were looking for. Tan V plus cotangent V over secant V cosecant V equals 1. And to prove that, we start with the more complicated side, obviously the left-hand side. And we write everything in terms of sine and cosine. So tangent is sine over cosine, cotangent is cosine over sine, secant is 1 over cosine, and cosecant is 1 over sine. So change everything accordingly. It creates a complex fraction, everybody. And you have 1, 2, 3, 4 fractions, and all of them have one simple LCD, sine and cosine, their product. So sine V, cosine V, multiply the top and the bottom line. So when we multiply these two, cosine goes away, we get sine squared. When we multiply these two, sine goes away, we get cosine squared. So the top is sine squared plus cosine squared. When we multiply these two, we get cosine goes away, we get sine squared. I'm sorry, when we multiply these two, they just cancel these two. Because it's a product. I read it as a plus for a moment. This completely cancels this one. So the product of these two is simply 1. So sine squared plus cosine squared is also 1. We established that it's equal to the right-hand side, and therefore we are done. Very simple, everybody. Prove ln of secant x plus tan x plus ln of secant x minus tan x equal to 0. And of course, they are in an absolute value because logs, they must have an argument which is positive. That's why they put it in an absolute value. So we keep the absolute value. So ln of absolute value of what? We are going to rewrite this as ln of this times that, reminding you of the following. Okay, this is called the product rule in the case of log. And now we are going to go from right to left. Now it doesn't matter, the base is B or E. So this one going to the right, that means ln of this expression times this expression in an absolute value sign. When we multiply these two, a plus b, a minus b gives us a squared minus b squared, secant squared minus tan squared. And again, I remind you of what we did before. Tan squared plus 1 is secant squared is one of those Pythagorean identities. So if I move the tan squared, I get secant squared minus tan squared equals 1. And we should know ln of 1 is 0. And that's a proof. ln of 1, we should know it's 0. Pretty straightforward, everybody. Sine squared of negative theta minus cosine squared of negative theta divided by sine squared of minus theta minus cosine of minus theta is equal to cosine theta minus sine theta. Obviously, we start with the left-hand side because it is more complicated. And to make sure we understand what we are dealing with here, this is sine of negative theta to the second power. And we should know every trigonometric function is an odd function except cosine, meaning sine of negative theta is negative sine theta, but cosine of negative theta is cosine theta. Therefore, this changes to minus sine theta, and this changes to cosine theta, this remains. This changes to sine of negative theta quantity squared, minus this changes to cosine of theta quantity squared. So take a look at what happens. This one, this means sine of minus theta, or minus sine theta squared. This means cosine of theta, because the same thing, right? Squared. This we will change it to minus sine theta, minus this will change it to cosine theta. I hope you see the odd and even as far as the type of function for trigonometric functions are concerned. Now, when you raise this to the power of 2, it doesn't matter you have a negative in front or not, it becomes sine squared. So minus cosine squared, that's the numerator, and the denominator doesn't change. So you're looking at a squared minus b squared. Which is a minus b times a plus b. Therefore, this is sine theta minus cosine theta times sine theta plus cosine theta. And for the denominator, we just take the negative sign out, becomes minus parenthesis sine theta plus cosine theta. The result is this one cancels out this one. So you have sine theta minus cosine theta over negative 1, which means negative sine theta plus cosine theta, or simply cosine theta minus sine theta, which is the right-hand side. And that proves the identity, everybody.